Let's look at an example involving metric prefixes. How many milliliters in 4.3 liters? We still start the problem the same way. We look for our starting units, so we're looking for a numerical value that has a unit associated with it, and so we find that liters are our starting unit. Next, we look at the units for our answer, and in the problem we notice it says how many milliliters. So milliliters is the units for our answer. And then we determine what relationship or relationships we know they're going to help us convert between liters and milliliters. And so we can write this based on what we know about the meaning of the prefix milli. A rule to follow when we're setting up the relationships between metric prefixes is to put the 1 with the prefix and put the meaning with the base. Notice that in our relationship we put the 1 with the milliliter, and then we put the meaning of milli, which was 10 to the minus 3, with the base unit of liters. So put the 1 with the prefix, put the meaning with the base. If you follow this rule, you will always get your metric prefixes set up correctly. Next, we want to estimate our answer. And it's a little bit harder sometimes with metric prefixes because we're not used to dealing with the metric prefixes or some of the units that we use with them. But we do know that a milliliter is much smaller than a liter, so we know that our number is going to be greater than 4.3. The more problems you do, the more answers you see, the better you will become at anticipating what the answer might be. Now we're going to set up our problem starting with our given value, 4.3 liters. Notice again, I have units written with my number, and I'm writing out the setup my problem before I do the calculation. Next, we want to cancel out liters, so I need liters on the bottom, and my relationship that I found had 10 to the minus 3 liters, and on the top I put the 1 milliliter. Now I can cancel out units of liters because one is in the numerator and the other is in the denominator. And I see that I have milliliters left, which is what I want for my answer. Now I can do the math and find that I have 4,300 milliliters. I next need to look at sig figs because I have 2 sig figs in 4.3. The relationship between metric prefixes is considered a definition, therefore it's an exact number, and is not considered when determining the number of sig figs in the answer. I would call this an ambiguous number because it's not clear if those zeros are meant to be significant or not, and so we're going to rewrite this number in scientific notation to be clear about the number of significant figures. So we have 4.3 times 10 to the third milliliters, which has 2 significant figures. Let's look at another example involving metric prefixes. This problem is slightly different because it involves 2 units, both with metric prefixes. We're still going to start the problem in the same way by finding our starting units and our units for the answer. When we look at our problem, we'll notice that we're given the kiloliters and we're being asked for deciliters. So those are our starting units and our units for our answer. Now when we're dealing with metric prefixes and going from one to the other, it's much easier to go through our base unit, which would be liters, rather than trying to do this problem in one step. And you'll find that many dimensional analysis problems take more than one step to solve. So first we need to look at our relationships with kiloliters and deciliters. We're going to start with the kiloliters, and we see that 1 kiloliter equals 10 to the third liters. I put the 1 with the prefix, and I put the meaning of kilo, which is 10 to the third, with the base unit of liters. Next, I do something similar with deciliters. So 1 deciliter equals 10 to the minus 1 liters. I put the 1 with the prefix, and I put the meaning of deci with the base unit of liters. Remember our rule, put the 1 with the prefix, put the meaning with the base. Now we can look at how we're going to set up the problem. So we start with 1.2 kiloliters because that was our starting unit in our given value. Next, we need to have kiloliters on the bottom of this step so that we can cancel out those units. And we put 10 to the third liters in the numerator because we know that 1 kiloliter equals 10 to the third liters. Next, we can cancel out units of kiloliters. We're going to go another step. Because we have liters on the top, we're going to put liters on the bottom of the next step. And then we can put our 1 deciliter on top. Now we can cancel out units of liters, and we're left with units of deciliters. Notice I'm still including units with all of my numerical values. And I set up the problem all in one step so that I can check all of my units before doing the calculator, rather than converting from kiloliters to liters, doing a calculation, and then converting from liters to deciliters and doing a second calculation. So I know my answer is in deciliters. Now I can go to the calculator and do the calculation, and I get 1.2 times 10 to the 4th. When I look at my significant figures, I see 1.2 has 2 sig figs. The other two relationships are both exact numbers, and so my answer has the correct number of significant figures.